In the last class, we discussed about, in the last video, we discussed about synchronous generator. What are the advantages of stationary armature? Armature is stationary in case of synchronous generator. In the last class, we discussed about synchronous generator has two types of rotors. One is silent pole and it is a smooth cylindrical type rotor. Now we go for armature windings are placed on stator. What are the advantages of stationary armature? You can see in the link in description. In the last video we explained what are the advantages of stationary armature. Now we go for armature windings of alternator synchronous generator. What is meant by winding? What is meant by conductor? What is meant by turn? What is meant by coil? Coil antemi, conductor antemi. What is coil? What is coil side, pole pitch, pitch factor, distribution factor, and EMF equation of alternator. Those we'll discuss in this video. Armature windings of alternators are different. Already told you what is the difference between DC and AC generator is. AC generator alternator has open windings, whereas a DC generator has shorted windings, because we taken the supply from stator, hence it is a open winding. The DC generator is shorted winding, that is short closed windings, and AC generator has open windings. The armature windings are different from DC machines. The three-phase alternator carries the sets of three windings arranged in slots such a way that exists a phase difference 120 degrees. Because in three-phase, the phase difference will be 120 degrees phase shift is required. All the conductors are displaced at 120 degrees. In DC machines, windings are closed, whereas in alternator, windings are open. The two ends of each winding is brought out, because in the AC machines the windings are open type winding, because the two ends has to be brought open and we are connecting external load to the alternator. In three-phase alternators, 6 terminals are brought out. Mana three-phase alternator lo kachithanga 6 terminals untayi, and star kani delta lo kani connect chestaru kabatti. In star as well as delta, if you connect, you can represent the alternator as like this. It is a star connected alternator. The 6 terminals or 3 terminals will be brought out. These are R, Y, B. Star connected. The neutral will be there. Or if you connect delta also possible. You can connect the alternator in star as well as delta. The two connections they given. Hence, 6 terminals are brought out from synchronous generator. 6 terminals are brought out which are finally connected in star or delta. Any one we can connect. According to that 6 terminals it is. Now, what are the important relations? What are the important definitions of before discussing the winding? Winding తెలుసుకునే ముందు వైండింగ్ అంటే ఏమి, టర్న్ అంటే ఏమి, కాయిల్ అంటే ఏమి అన్ని తెలుసుకోవాలి ఖచ్చితంగా. కండక్టర్, వాట్ ఈస్ మీన్ బై కండక్టర్? It is a part of wire which is under influence of magnetic field or producing EMF is called conductor. Conductor means simply one conductor means it is a wire which induces the EMF is called one conductor. One turn means when you take two conductors and join together, then it is a turn. Suppose these are the two conductors. If you join these two with the help of a end connections, then it is forms a turn. Coil, when two or more number of turns grouped together, then it is forms a coil. Coil may be consist of more number of turns. Number of turns are wound on one coil. Coil side, it consists of many number of turns. What is coil side? Coil consists of many number of turns. The part of the coil insert is called coil side. Each slot, one coil side will be there. Similar to DC generators or DC machines also, we require all these important relationships. One is coil side, coil, turn, conductor. ఇక్కడ కండక్టర్ని 2 కండక్టర్లు కలిసి ఒక టర్న్ ఫామ్ అవుతాయి. నెంబర్ ఆఫ్ టర్న్స్ ఒక కాయిల్ ఫామ్ అవుతాయి. ఒక కాయిల్ సైడ్ అంటే ఒక కాయిల్ సైడ్ వచ్చి ఒక స్లాట్లో ఒక్కొక్క కాయిల్ సైడ్ ఉంటుంది. అంటే నెంబర్ ఆఫ్ టర్న్స్ ఉంటాయి కదా, మనం వైండింగ్ వేసేటప్పుడు చూసింటాం కదా. వైండింగ్ చేసేటప్పుడు కానీ జనరేటర్లో కానీ మోటార్స్లో కానీ మన స్లాట్స్లో నెంబర్ ఆఫ్ వైండింగ్స్ పెడతా ఉంటారు. అంటే అది అంతా కలిపి ఒక కాయిల్ అనుకుంటే ఒక స్లాట్లో ఒక కాయిల్ సైడ్ ఉంటుంది, ఇంకో స్లాట్లో ఇంకొక కాయిల్ సైడ్ ఉంటుంది. దాన్ని కాయిల్ సైడ్ అంటున్నాం. పోల్ పిచ్ అంటే ఇక్కడ వెళ్ళాలి. డీసీ మిషన్స్లో వచ్చి ఉంటుంది కదా పోల్ పిచ్. Pole pitch is defined as the number of slots per pole is called pole pitch. The number of slots comes under one pole is known as pole pitch. It is the distance between two adjacent poles is also known as pole pitch. The pole pitch is also known as distance between two adjacent poles. Pole pitch. If you consider two poles like this, if you consider the two poles, two magnetic poles on the rotor, or if you consider this also another pole, the distance between two adjacent poles is known as pole pitch. ఈ పోల్ రెండు మధ్యలో ఉండే డిస్టెన్స్ని పోల్ పిచ్ అంటారు కదా. ఇక్కడ ఎన్ని స్లాట్స్ ఉంటాయి? ఇఫ్ యూ కన్సిడర్ DC మిషన్, it is a slot, number of armature conductors are there, but quite opposite for alternator. It is opposite. ఇది ఇక్కడ ఉంటుంది, పోల్స్ వచ్చి రోటర్లో ఉంటాయి, బట్ ఇక్కడ స్టేటార్లో పోల్స్ చూపిస్తున్నా ఎందుకంటే పోల్ పిచ్ వైండింగ్ అంటే డిస్టెన్స్ బిట్వీన్ టూ అడ్జసెంట్ పోల్స్ ఈజ్ నోన్ యాజ్ పోల్ పిచ్. ఈ పోల్స్ మధ్య ఎన్ని స్లాట్స్ ఉంటాయో అన్ని స్లాట్స్ ఆల్సో నోన్ యాజ్ నెంబర్ ఆఫ్ స్లాట్స్ కమ్స్ అండర్ వన్ పోల్ ఈజ్ నోన్ యాజ్ పోల్ పిచ్. Pole pitch or number of slots per pole is known as pole pitch. It is the center to center distance between two adjacent poles. Okay, we have seen that one rotation of conductor, two poles are responsible for 360 degrees. Two poles will be responsible for 360 degrees. Four poles will be 720 degrees. Similarly, 180 degrees of electrical is similar to one pole. If you consider two poles are nothing but one pole is responsible for 180 degrees. 180 degrees electrical is also called as one pole pitch. Consider two pole 18 slot armature of an alternator. Pole pitch is number of slots divided by number of poles. Number of slots are 18 by 2 gives 9 or 180 degrees electrical. This pole pitch 9 is equal to 180 degrees electrical. Okay, pole pitch and distance between two poles. Now go for another topic. The number of slots per pole is also defined as n అనుకుంటున్నాం ఇక్కడ. We are considering as n. Number of slots per pole is known as n. Assume that for deriving breadth factor, distribution factor in case of electrical missions 3 alternator, we assumed as a pole pitch as n. Pole pitch n equal to 180 degrees equal to slots per pole. Number of slots per pole is known as pole pitch. This is number of slots per pole, or we can write as number of slots per pole is known as pole pitch. What is known by slot angle? Slot angle, the phase difference contributed by one slot in electrical degrees is known as slot angle. If you consider the slots, you can see that slots. If you consider the stator, it is the stator of this synchronous generator. If you consider the stator, number of armature windings are there, number of slots are there. The EMF contributed by each slot, this is the EMF generated in one slot. This coil may be connected another slot. Slot angle beta we assume, that also we have to remember. What is beta? The phase difference contributed by one slot in degrees electrical is called slot angle beta. Beta we have to assume slot angle beta. Beta can be represented as 180 by n. One slot angle equal to 180 by n, where n number of conductors, when number of slots are there, then we can calculate beta equal to 180 degrees divided by n. For example, number of slots are 18, number of poles are 2, pole pitch is n equal to 180 by 2, that is equal to 9. Now beta equal to 180 by n. Now first we have to calculate what is n, pole pitch. Pole pitch equal to 18 by 2 equal to 19, that is the pole pitch. If you know pole pitch, you can calculate a slot angle. The EMF contributed by one slot in degrees is known as slot angle. Beta equal to 180 by 9, that equal to 20 degrees. Now assume that E1 is the EMF induced in one slot, another E2 is the EMF induced in another slot, conductor 1 and conductor 2 conductors are there. Two conductors or two slots or one coil will be E1 is the EMF induced in one conductor, E2 is the EMF induced in another conductor. The phase difference contributed by each slot is known as the phase slot angle beta. Beta degrees equal to 180 by pole pitch, 180 by 9, that equal to 20. That is EMF induced in conductor which are placed in slots and adjacent to each other. There will exist a phase difference of beta degrees in between them. అంటే ఇది క్లియర్గా అర్థం కావాలంటే మనకు ఒక if you consider an armature of synchronous generator, it is the armature of synchronous generator. Number of slots are there. Stationary armature, it is the conductor 1, conductor 2. This conductor may be this is another slot having number of conductors. EMF induced in this conductor is E1, number of conductors. E2 is another conductor. What is the phase difference? The difference, assume that it is E2, it is En, assume that number of slots are there. The phase difference contributed by each slot is known as slot angle beta. Beta equal to 180 by N. This formula is important. 180 by N. This is beta equal to 180 by N, that is N, where N is known as pole pitch. Now types of armature windings we are used in synchronous generator: single layer and double layer winding, full pitch winding and short pitch winding, concentrated and distributed. These are the three types of windings we are using in synchronous generator: single layer, double layer, and full pitch and short pitch, concentrated and distributed. If all the conductors are concentrated one slot, that is concentrated winding, distributed winding, full pitch and short pitch. If the number of slots per pole per phase is equal to an integer, then it is a full pitch winding. If it is number of slots per pole per phase is not an integer, then it is known as short pitch winding. If one conductor per slot, then it is single layer. If two or more number of conductors, double layer winding, multi-layer winding. Which type of winding we are using in synchronous generators? Let us discuss now. Okay, as you told that number of slots per pole in single layer winding, only one coil side per slot, it is single layer winding. In double layer winding, two coil sides per slot, top layer and bottom layer. Assume that it is assumed that these are the slots, the conductors are laid top layer and bottom layer. This is a multi-layer, n number of conductors, m number of coil sides will be presented. If two coil sides per slot, one at bottom, another one is top of the winding, is called double layer winding. Single layer winding means only one coil side per slot. Single layer winding is used only in small AC machines, whereas double layer winding is more common above 5 kilowatt synchronous generators. More than 5 kilowatt we have to go for double layer winding, because the higher currents has to be withstood by the stationary armature, hence we go for double layer winding. The advantage of double layer winding over single layer winding are it is easier to house the windings in slots during repairs. We can, if any fault occur in synchronous generator, we can easily replace one coil easily. Another advantage is lower leakage reactance and therefore better performance will be there. Better EMF waveform, sinusoidal, more sinusoidal EMF will be generated if we are using multi-layer, double layer winding. It is more economical. Now we go for full pitch winding, short pitch winding. Full pitch and aim is short pitch and aim. Why it is called full pitch? Why it is called short pitch? The peripheral distance between two adjacent poles is known as pole pitch. It is the distance between two adjacent poles is known as pole pitch. Pole pitch equal to 180 degrees or pi radians. Full pitch winding coil winding is defined as a coil whose two coil sets are distance equal to one pole pitch. It is known as full pitch. You can see that full pitch winding. You can see this. This is the north pole and south pole. one coil is placed, coil A dash is placed on south pole, coil A is placed on north pole. Now full pitch winding it is. The distance between two sides of the coil is equal to one pole pitch, then it is full pitch winding. If it is not equal to pole pitch, then it is short pitch winding. Assume that it is a winding N and S. We are placed. Coil span is equal to, it is known as choding angle. It is one coil side is placed in north pole, another coil side is not placed. It is less than some angle, that is known as choding angle. Another coil side is placed, leaved one slot, after that we place short pitch winding. Coil span is equal to choding angle epsilon, coil span is equal to 180 minus epsilon. The distance between north pole and south pole is 180 degrees. What is the coil span here? 180 minus E. That is the difference between full pitch and short pitch winding. Full pitch winding coils is defined as a coil whose coil side is distance equal to one pole pitch. Distance between two coil sides equal to pole pitch is the full pitch winding. Similarly, if the distance between two coil sides is not equal to pole pitch, then it is short pitch winding. Short pitch winding. If the coil span, coil pitch is less than 180 degrees, because one between distance here north pole to south pole, what is the electrical degrees? 180 degrees. But short pitch winding, the distance is not exactly equal to 180 degrees. That is known as short pitch winding. The angle at which the coil span departs from 180 degrees electrical degrees is called choding angle. This is the angle at which the coil span departs. 180 degrees electrical undalsindi taggindi kabatti, that is known as choding angle. Choded windings mostly we are using in alternators. What is the advantage of short pitch winding? We are mostly used in synchronous generators. Short pitch windings are mostly used because of advantages. In actual practice, short pitch coils are used. It has so many advantages. The length required for end connections of the coil is less, because if you use the total coil, the length end connections gives more copper connections, more copper we are utilizing. But if you reduce the copper size, the end connections, the length of the copper wire required for end connections is reduces. That is, inactive length of winding is less, so copper consumption, copper winding requirement is less, it is economical. And another advantage is short pitch eliminates high frequency harmonics. It is very important. Short pitch windings, whereas full pitch windings have harmonics, hence short pitch windings are reducing the harmonics, hence waveform of induced EMF is more economical, more sinusoidal, not economical. Short pitch eliminates high frequency harmonics, hence EMF waveform which is induced in armature, that is more sinusoidal. And another advantage is a high frequency harmonic gets eliminated. High frequency harmonics gets eliminated, eddy current and hysteresis losses which depends on frequency gets minimized and increase the frequency. Harmonics eliminate అయ్యాయంటే కంపల్సరీగా లాసెస్ తగ్గుతాయి. హార్మోనిక్స్ ఇఫ్ దే ఎలిమినేటెడ్ ఎడ్డీ కరెంట్ అండ్ హిస్టరీసిస్ లాస్ డిపెండ్స్ ఆన్ ఫ్రీక్వెన్సీ. If the frequency is related to harmonics, the ripple frequency or harmonic frequency depends on frequency. Hence, eddy current loss, hysteresis loss will be eliminated. That increases the frequency. That increases the efficiency. System of will be increases. అంటే షార్ట్ పిచ్ కాయిల్స్ హ్యాస్ 3 అడ్వాంటేజెస్. వన్ ఈజ్ లెంత్ తక్కువ అవుతుంది కాపర్ ఎండ్ కనెక్షన్స్లో, హై ఫ్రీక్వెన్సీ ఎలిమినేట్ చేస్తాయి. థర్డ్ వన్, ఎడ్డీ కరెంట్ లాసెస్, హార్మోనిక్స్ గెట్స్ ఎలిమినేటెడ్ అని చెప్పాం కదా, దానివల్ల ఎడ్డీ కరెంట్ లాసెస్, హిస్టరీసిస్ లాసెస్ తగ్గుతాయి కాబట్టి ఎఫిషియన్సీ ఇంక్రీజ్ అవుతుంది. దిస్ ఇంక్రీజెస్ ఎఫిషియన్సీ, నాట్ ఫ్రీక్వెన్సీ, ఇట్ ఈస్ ఎఫిషియన్సీ. Now we go for another topic. What is concentrated, what is distributed winding? Concentrated winding, already told you, if one conductor considered only one slot, then it is a concentrated winding. If the conductor is distributed number of slots, the winding is distributed number of slots, then it is distributed winding. In 3-phase alternator, there is a 3 different sets of windings for each phase, depending on total number of slots and poles. Let m equal to number of slots per pole for phase, where m is known as, already we told that, n per pole. N is known as number of slots per pole by phase. N by phase or n by phase. It is number of slots per pole is known as pole pitch by phase divided by phase gives M. For 18 slots, 2 pole conductor, 2 pole alternator, N equal to 18 by 2 already we discussed, M equal to 9 by 3, that is equal to 3. So 3 slots per pole per phase. అంటే ఒక్కొక్క పోల్ కింద 3 స్లాట్స్ ఉంటాయి. 18 స్లాట్స్ ఉండే ఆల్టర్నేటర్లో 2 పోల్స్ ఉంటాయి. ఒక్కొక్క పోల్ కింద ఎన్ని స్లాట్స్ ఉంటాయి? 3 స్లాట్స్ ఉంటాయి. అవి ఎలా క్యాలిక్యులేట్ చేస్తారు? స్లాట్ యాంగిల్ బీటా ఈక్వల్ టు 180 బై ఎన్ అండ్ ఎం ఈక్వల్ టు 9 by 3. ఇక్కడ ఇంపార్టెంట్ థింగ్, 8 pole 2 pole alternator it is a 2 pole alternator. Assume that it is a 2 pole, N and S, 2 poles are there. Total slots are 18 slots total. P equal to 2 poles, number of slots equal to 18. Number of slots per pole, pole pitch equal to 180 by 18 by 2. Number of slots divided by number of poles or number of slots per pole is known as pole pitch. That equal to 9. Now it is a 3 phase. M equal to number of slots per pole, already we calculated 9 by 3 phase, it is 3. Now number of slots per pole per phase, అంటే ఒక phase winding number of slots per pole per phase, 3 slots per pole per phase it is. అంటే ఒక్కొక్క పోల్ కింద ఒక్కొక్క ఫేజ్కి సంబంధించినవి 3 స్లాట్స్ ఉంటాయి. ప్రొవైడింగ్ ఆల్ కండక్టర్స్ ఇన్ 1 slot అండ్ రిమైనింగ్ 2 slots empty and it is known as concentrated winding. ఇఫ్ 3 slotsలో డిఫరెంట్ కండక్టర్స్ ఒకే కండక్టర్స్ని ప్లేస్ చేసామంటే దట్ ఈస్ డిస్ట్రిబ్యూటెడ్ వైండింగ్. కన్సిడర్డ్ వైండింగ్ ఆల్ కండక్టర్స్ ఆర్ కాయిల్స్ బిలాంగ్స్ టు 1 phase ప్లేస్డ్ ఇన్ 1 slot ఓన్లీ. డిస్ట్రిబ్యూటెడ్ వైండింగ్లో దీని క్వైట్ ఆపోజిట్ అనమాట. ఆల్ కండక్టర్స్ విల్ బి డిస్ట్రిబ్యూటెడ్ ఈక్వల్లీ 3 slotsలో. ద డిస్ట్రిబ్యూటెడ్ వైండింగ్ కన్సిస్ట్ ఆఫ్ ఆల్ కండక్టర్స్ అండ్ 1 pole 1 phase డిస్ట్రిబ్యూటెడ్ అమాంగ్ ఆల్ స్లాట్స్. దీనికి ఆపోజిటే ఇది, ఇట్ ఈస్ క్వైట్ ఆపోజిట్. ద డిస్ట్రిబ్యూటెడ్ వైండింగ్ కన్సిస్ట్ ఆఫ్ ఆల్ కండక్టర్స్ అండ్ 1 pole of 1 phase డిస్ట్రిబ్యూటెడ్ అమాంగ్ ఆల్ స్లాట్స్, దెన్ ఇట్ ఈస్ కాల్డ్ డిస్ట్రిబ్యూటెడ్ వైండింగ్. It is simple example we consider 18 slot 2 pole alternator. Now M equal to number of slots per pole per phase is 3. 3 slots per pole per phase it is. 3 slots per pole per phase it is. If 3 slots all remain, omitting 2 slots, keeping the 2 slots empty and providing all conductors in 1 slot instead of 3 slots, it is a concentrated. But distributed the all 3 slots, it is known as distributed winding. In practice we are using double layer, short pitch and distributed winding. Distributed winding gives more EMF and ripples also will be less. So in practice double layer, short pitch, distributed windings we are using. It is important thing. In practice double layer, short pitch and distributed winding we are using. Double layer అంటే ఏమి, షార్ట్ పిచ్ అంటే ఏమి, వాట్ ఈస్ డిస్ట్రిబ్యూటెడ్ వైండింగ్. పర్ఫార్మెన్స్ ఆఫ్ ఆల్టర్నేటర్ విల్ బి ఇంక్రీజ్ ఇఫ్ యూ యూజ్ డబుల్ లేయర్, షార్ట్ పిచ్ వైండింగ్, డిస్ట్రిబ్యూటెడ్ వైండింగ్. ఓకే, నౌ వాట్ ఆర్ ద అనదర్ వైండింగ్స్? ఫ్రాక్షనల్ పిచ్ వైండింగ్, ఇంటెగ్రల్ స్లాట్ వైండింగ్, ఫ్రాక్షనల్ స్లాట్ వైండింగ్. అనదర్ టైప్స్ ఆఫ్ వైండింగ్స్. If an integer, it is a, if m equal to an integer, then it is a integer 2 we are obtaining. Now the value of number of slots per pole per phase decides the class of winding, where m equal to number of slots per pole per phase, that is when the value of mn is an integer, then winding is called integral slot winding. When the value of m is an integer, then the winding is called integral slot winding. For example, if you consider 4 pole 24 slot alternator 3 phase, number of slots per pole per phase equal to 24 by 4 by 3, that equal to 6 by 3 equal to 2.